We are going to talk today about reflections. What happens when you take a selfie and you have something on your shirt?
Transformation. Mirror.
It's backwards, right? Okay. It gets reflected, but it's backwards. Okay. When you were kids, did you ever try to like write a message so that you could read it when you held it up in the mirror? Like you had to write backwards so that when you held it up in the mirror, you could read it? Never, that wasn't a thing? Okay. All right. Okay, so we're going to talk about reflection. So a reflection is a type of, it's a rigid transformation. What does rigid mean? We talked about it yesterday. Yeah, they're congruent. The size is not going to change. Okay. So with the reflection, you are going to be given a line. It is either going to be a vertical line, a horizontal line, or y equals x or y equals negative x. Laugh at me, that's rude. I'm trying to really be in my character today. I almost did a mindful minute, but I wasn't like exactly sure.
You should have done that. So funny. Do it next
You should. Okay, I'll keep that in mind. Okay. She probably.
Mystery said that she likes geometry.
All right.
I don't know this.
So let's talk about if this line was our line of reflection. Okay. Then what's going to happen is C prime is going to be the same distance away from the line of reflection. B prime is going to just fold over, right? And A prime. So what happens is, right, we look in a mirror, it gets a little backwards, okay? But like C and C prime are both the same distance away from our reflection line. A and A prime are the same distance away from our reflection line. Does that make sense? Mm-hmm. Like if we were to count the space, right, it would be the same. Okay. Kind of like when you look in the mirror or you take a selfie and you have words on your shirt, okay? If Clark were to look in the mirror, the monarch is going to be the same, right? It's just going to be read backwards. Thank you.
Drama.
Okay, we need to stop. We need to stop. Okay. Our line of reflection is our mirror that we're going to use. Okay. Okay, so what I need you to do is I need you to turn to the page 4. Keep your student, we're not done with the student journal, but go to page 4 in your packet. So what we are going to do is we are going to take the coordinate 3, 4. So everybody plot the coordinate 1, 2, 3, 1, 2, 3, 4. Pull out the coordinate P. Hello. Brayden, your shoes.
Yeah, I'll take you back. Okay, thanks. Let's go. I'm not
Thank you, I'm sorry.
Interrupt anytime, my dearest pumpkin.
I'm never letting you off.
Shut her open.
It was shut.
Oh, you're a pumpkin.
Well, how did you do this one? You had to get the C's together, right?
Yeah.
Over here, you gotta get the W's together.
They were like, hey, you look like this. I'm like, no, they're not home.
Add or subtract to where the W's get together.
Exactly, I'm not doing
Yes, I
Do what you can. All right, do you have this plotted? We are going to reflect across the line x equals -1. So x equals -1. Show me with your arm, what kind of line is that? Do you have a question? Oh! I'm sorry. Not sure what that was. So here's our line, x equals -1. So if I want to reflect this coordinate across the line, x equals -1, we need to know how far it is. So I am going to use 1, 2, 3, 4. It's 4 away, right? So we're gonna go 1, 2, 3, 4 the other way, and P prime is right here at -5, 4. Is that right? -5? 1, 2, 3, 4. Yep. Boom, done. Got it. Okay. All right, let's go to example 2. Oh, this was very kind of them to already have it plotted for us, right?
Oh, wow.
So we need to reflect this about the x-axis. So I'm going to make a dotted line on the x-axis so we know that that's what we are reflecting it about. Okay? Yeah. It's fine. I'm just using mine. You can use a solid line. Okay. Now, so here's coordinate A right here. Let's count. How far is it perpendicularly? How far is it from our reflection? 1, 2, 3. Is it 5?
Yes.
So we're gonna go 1, 2, 3, 4, 5 and plot A prime. Okay. How far away is B? 4 away from our x-axis. So let's go 1, 2, 3, 4. Okay, but now I'm confused. How far is C away from our line? Ah, so C and C prime are the same. If it is on the line of reflection, it's not gonna move. All right, do number 3 without me. I'm gonna fill up my water. Were you doing number 3?
It's like the same thing.
Yeah, it's on the y-axis. Number 2 is y-axis.
Really bad job.
Oh, nice.
I know, but it's crossing. Why?
Yeah, it's gonna overlap. It'll be okay.
Oh.
It's like
I don't get it.
when you stand in those like houses of mirrors and you only put like
Oh, those are,
half of your body.
those like make me go crazy.
Crazy.
Yeah.
I was
Oh,
crazy
those are
once.
Yep.
Okay, so if you wanna really freak out Brayden, take him to a house of mirrors.
Yeah, I remember seeing a weird thing where it was like an illusion. It was like one of those things that like it's like a mirror on both sides and you put something inside and close it with light and then it projects like a 3D image that it actually isn't there. Except they created that on like a massive scale. They can make like an entire truck that isn't there.
I
So
don't
let's
get
say
it.
you can look at
I don't get it.
it.
Okay, have you done example 3?
Yes.
Okay,
I don't
Sam, what does A prime get mapped to?
Oh, 4 to 5.
Are you sure about that?
3 to 5. My bad.
3, 5, okay. Ben, where do we put B prime?
Negative 4, 5, 4.
B prime is negative 4, 4?
Yeah.
Okay,
Yes, sir.
yes, sir.
Yes.
Ma'am would be fine. Or almost here. Okay, Nora, where does C prime go? Okay. What do you think so far?
Makes sense. Easy.
Makes sense. Okay. So how about you go ahead and plot 3, 4. P 3, 4. The line y equals negative x is now our line of reflection. What does that look like?
Oh, wait, it'll just still be a line.
wait.
But it's negative 1x. So
Isn't
just go
it
back
the
one.
line that's like the negative with the X line?
No, it'll be this way. It'll be
one.
it'll be
it's like-
horizontal. Oh.
Oh, what?
Oh, yeah, that makes sense. Yeah,
I'm
because
I don't
y
get it.
equals- Oh, yeah.
If we're talking about y equals mx plus b and our line is y equals negative x, this is like y equals negative 1x plus 0. So our y-intercept is 0 and our slope is negative 1.
Oh, so it's not gonna be like slopes into the.
Yeah, I just.
So the only 2 lines I'm gonna make you graph that have slope are either y equals negative x or y equals positive x. You can do it. So now, let's just count how far P is away horizontally from our reflection line. 1, 2, 3, 4, 5, 6, 7. Which way am I gonna bounce?
Right on this.
That's
Would
not
it
how
be
I
down?
did it.
Yes, we're gonna bounce down. 1, 2, 3, 4, 5, 6, 7. Here is my new coordinate. P prime is now negative 4, negative 3. When it's y equals negative x. So you can like learn all the rules, but what I want you to do is be able to visualize what's happening.
Yeah.
If I come to the line, I'm gonna bounce this way for the
Yeah,
reflection.
because, you know, if it's straight on, then it would just bounce back. But if
Mhm.
it's tilted, it won't. Like if you're looking at a mirror, it will tilt up.
Mhm,
So with this, it tilts down.
mhm.
This is the opposite.
This doesn't make sense.
If you tilt a mirror, you will see more up. Because that's because it bounces up. If you have a mirror straight, you see directly straight. Tilt it up, you're not. How am I not? Have you guys never looked at a
No,
mirror?
guys, no, this is what he's talking about. Like if the light goes like this, it's like this. But if it goes like this, it'll go.
Yeah.
Thank you, Curious George.
I love
Okay.
mirrors. Bro,
He's actually not a monkey because he doesn't have a tail.
Alexa, where do you think this one should go instead?
I don't really know either.
Okay, so here's the deal. Like, if we look,
Why can't you count 3 from
Like-
0? And then
like this would be perpendicular,
yeah.
but we're not gonna do that because we don't wanna do like, we don't wanna make this complicated with distance formula and where's the 90-degree angle, blah, 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 blah. It is created if we go boom, boom. Mm-hmm.
It's like you get to the x-axis and then go over 4.
So easiest way to do this is to count to the line and then go that same distance the other way. Okay, so let's now, let's go to example 5, where we're going to reflect about the line y equals x. So graphing the line y equals x looks like this. Graph it. Hey, Brenda. You didn't want to show me work on this? You get a point for work. You're missing 1, 2, 3 points right now, just on that front page. Just because it didn't show work. Okay. Okay, so let's talk about point A. Okay. Point A is 1, 2, 3, whoops.
It's 5.
It's 8 away from our line of reflection. Alexa, did you count that? Okay, so now which way are we gonna bounce?
Down.
Down. 1, 2, 3, 4, 5, 6, 7, 8. So here's A prime. Now A was at -3, 5. Where's A prime? 5, -3. Okay.
Reciprocals.
Don't know if that's what we would call it, but it's like an inverse X and Y switch. Okay. What happens to B prime? Okay, B prime gets to stay. And then C is only 1 away here. So it's gonna bounce up 1. So C prime is at 0, 1. Oops.
Yes.
It is sort of
It's like
weird.
Is you realize like the whole point of a reflection is that. Okay. Okay.
Crazy. This is real.
Okay. I want you to go back to page 99. Okay. And Alexa, maybe this will help. Okay. So P and P prime are going to be the same distance away. Okay. And they're going to be, if you draw the line through it, like I showed you, they're always going to be perpendicular. Okay. So we're talking about like they have the same distance away perpendicular. So if we have one of those lines with slope, okay, we're not going to necessarily count in that perpendicular fashion, but if we were to connect them, they are going to be the same distance and perpendicular. I don't think I ever said that. Okay, let's talk about what's called a glide reflection. Any idea? Okay,
It's just it just like glides across, like it doesn't change or anything, or it doesn't like shift down. It just slides.
when did we talk about slides? Yesterday. Yeah, so we are going to do a translation, then a reflection. Good, great job. Okay, so now we're gonna go to example 6. Will you please graph ABC for me?
I get it.
Translation.
The X plus or one.
Okay.
It's supposed to go off the graph.
No, it's not gonna go off the graph. What?
Negative 12.
It's
Oh my
negative
God,
12, it goes off by
Is
one.
it negative?
It goes off by 1.
Did I tell you to do that?
3, 6, 9.
Okay, it goes off the graph, fine. So where is A prime gonna go?
Problem solving.
So, that would be -9, 2. Is that the new?
Yes.
Is that the new A prime?
Negative 9 too.
And B prime is now
Negative 6.
3.
3.
And C prime is now, okay. Now we're gonna take those coordinates, yes, and we are going to reflect them over the X axis. So I have highlighted my X axis, all right? And let's see, we'll go blue. So C double prime is going to reflect down, and now it's -5, -1. B prime, double prime, is now -6, -3. And A double prime reflects down and is now -9, -2. Oh, that was bad. No, it's not. I didn't do it far enough. It is -9, -2. I just didn't graph it right. There we go. A hot mess. Okay. All right, there's one more thing we need to talk about, and then I'll let you know what your homework is. So go back to the student journal. Yes. Okay, line symmetry. Oh, maybe I should not have tried that.
For the next class, you should do a month.
I brought my soy sauce, it's just too hot.
Okay, so I want to know how many,
Oh my gosh.
Oh my
I always
God.
get this on Excel when I used to do it.
okay,
I've never done that.
What is that?
is it symmetrical? Pretend it actually was drawn correctly. Do you see how it's symmetrical about that line? Pretend that it's symmetrical about that line. Anywhere else?
Yeah, in the middle.
Vertically?
And then
So how many lines of symmetry does it have?
6, 2, 3.
How many lines did I draw? There are 4 lines of symmetry. Wow.
It looks like a pizza. Oh, concave figure. It's a concave.
I remember